So now we're getting into inverse functions here on page 54, question 12. So we have our original equation, f of x equals x squared plus 3. First thing we have to do is write the equation of the inverse. So what we do is obviously we write it out with y, we then switch it. So x is going to be equal to y squared plus 3. X minus 3 is equal to y squared. Whenever we square root something, we have both the positive and negative root, which means y is equal to plus minus square root of x minus 3. Now, if we want to graph f of x and f negative 1 of x, what we're going to do first is write out points. So if we were to have our table of values here, we would have x, y. So I'll just use 0, or we'll use negative 1, 0, and 1. And then our y value is going to be x squared, so that'll just be 1 plus 3, so 4. 0 is going to be 3. And then this, once again, is going to be 4. Whereas with our new function, or I shouldn't say a function because this is not a function, is that our x values are going to have two y values. In other words, this is actually not going to be a function. So if we were to put in a same negative 1, 0, or actually, hold on, because our domain is x must be greater than or equal to 3. So actually, what we're going to use is So what we're going to use is 3, 4, and 5. So on the negative graph is what we'll do first. So it'll basically be 3 minus 3, so 0. So this is still going to be 0. We then have 4, which is just 4 minus 1, so 1. So we'll have plus minus 1. And then 5 will have plus minus root 2. So if we were to graph these two functions, we have x and we have y. So negative 1 is going to be at about 4, 0 and 3, and then we'll call that 4 again. Does not have to be super exact. If this were an exam, your teacher might want you to put more, or for the time being, this is fine. Then we're going to do this one. So 3 and 0 is going to be something like here. We'll just put that point down as 3 and 0. And then we'll call this 4. So it'll be plus minus 1. And then 5 plus minus root 2. And we now have our inverse of f negative 1 of x. And then I'm just going to fill in these points. So 3, 0, 1, negative 1, and then 5, negative root 2, 5 root 2, and then you would fill in all these points. So now, next question is, restrict the domain so that the inverse function is a function. So now, if we think about here, because obviously this does not pass the vertical line test, what we can do is we can restrict the domain of f of x so that our inverse only has about half. So one way that we can do this is we can say x, because if we look at this function, the right side of this, or the axis of symmetry, is right here, which means that if x is greater or equal to 0, that is a possible domain, and then obviously x er, because we will then get an inverse that is only the bottom half. As well, we can do x has to be less than or equal to 0, because this would now mean, of course with xer, because this would then mean we only get the top half of the graph. So now, if we were to graph this function, it would look something like, obviously not this exact, or it would be more exact than this. This would be f of x, and then this would be negative 1 of x, whereas this one would look somewhat like this for f of x, and then it would look f of x, and then it would look somewhat like this for f of negative 1x, or the inverse. In other words, with a parabola, we can either restrict it on one side or the other, and each of those will be able to give us a function as the inverse. So that's pretty much it for the inverse function. If you're wanting any customized help, you can check the link below.